Okay. Hello and welcome to Kickstart online webinar here at Glasgow Caledonian University. My name is Branka Dimitrijević and I will moderate today's event. If you are joining our webinars for the first time, I should say that we disseminate the outcomes of feasibility studies and academic consultancies that have been undertaken by the universities involved in our project. The project supports collaboration of 7 Scottish universities and small to medium-sized enterprises operating in the construction sector in Scotland. The project is funded by European Regional Development Fund and Scottish Government CIC program, which is now managed by Scottish Funding Council. This is a live event, so if there is a fire alarm, we will have to stop, but we will continue later. If you cannot join us, you can always watch a video recording of this webinar tomorrow. We plan to finish presentations around 1:30, but you can start asking questions by using chat facility at any point during the presentation. The questions will be answered after the presentation, and we will close around 2 o'clock. We now offer a live transcription service as a part of our online broadcasts. The presentation is transcribed live in a pop-up window as the webinar takes place. By providing this service, we hope to make our webinars as accessible as possible. The instructions are provided in a login email that you have received this morning. So today's webinar's title is Sustainability and Energy Efficiency of 3 New Build Dwellings in Aberdour. This is the study whose outcomes have been delivered by Edinburgh Napier University, and we have a speaker here from Edinburgh Napier, John Stinson. And the study was undertaken for the benefit of the company called Phoenix. So we have a speaker here who will speak for Phoenix, Stuart Hanna, who is also an architect in Ed Architects. And we also have here Drew Crawford of Phoenix Joinery, who will be joining our Q&A session at the end. So I would kindly now ask John Stinson to start his presentation.
Thank you, Branka. And I'd like to be one of the first to thank Kickstart here for the fantastic opportunities that we have had through here at Edinburgh Napier University. Thank Branka and the team here, Craig, for the fantastic opportunity to facilitate the work here with Phoenix and with Drew and with Stuart, and also the resource that Kickstart has provided and the archive system they're going to be developing after the Kickstart project has finished. So I'll just go on now to talk a little bit about our involvement with Phoenix. Essentially, I'll be talking first and describing the project partners, the objectives, the aims, and introducing what we set out to achieve. I'll be passing over to Stuart, who'll be going through different aspects of design ethos, his design strategy, and all the decisions that were made when putting together the drawings. They'll come back to me. I'll describe what we're talking, describe the report, the outcomes, methodology, etc., and then we'll wrap up then with some conclusions. First of all, just the project partners. As Branka mentioned, this was an academic consultant, or a feasibility study, a partnership between ourselves and Phoenix. Phoenix are specialists in renovation, renovation projects, with the aspiration to develop into new build designs and looking at making a future towards low carbon and energy efficient homes. Ourselves at the CIC, we've presented here many times before. We are a centre within the Institute for Sustainable Construction at Edinburgh Napier, and a lot of our work is spent on feasibility studies supporting SMEs and doing post-occupancy evaluation and review of renewable technology. So just a brief introduction to the report. 3 homes were designed in this particular project, and they were to be built in a rural setting in Aberdour. The designs were to facilitate the use of the latest renewable low carbon technologies with a focus on energy security, decentralising power and heat source, and investing in the future of technologies. So they develop an off-grid sustainable housing solution that could possibly be replicated on a larger scale. Just a brief sets of aims and objectives. Essentially, we were set out to investigate the potentials and the possibilities to create off-grid homes using government supported technologies and renewable systems as a starting point. The report was set out to create a better understanding and to economically assess different alternatives for Phoenix, for Drew and Stuart here, to see how they can move forward and give some authoritative independent advice on different technologies that they can use. The report then is going to go further, which we'll speak about a little bit later, and be a key part of the planning statement submission to Fife Council. And also we set out to assess each of the properties that were designed under the Scottish Building Standards Section 7, and to see how they compare to that. So just now I'm going to pass over to Stuart Hanna from Ad Architects, and he's going to go through aspects relating to the site and to the design of the properties.
Okay, thanks, John. The first thing I'm going to speak about is why this site specifically was chosen. Phoenix are a Fife-based company, and they're well aware of Fife Council's ambition to be a green council, so therefore Phoenix looked for a site within Fife. The site selected, there's several things that they looked at. They looked at different sites, but many sites proved unsuitable due to the urban setting. There's overshadowing, there's noise pollution, various things like this. This site has very open aspect, it has southerly views. It makes it possible for PV panels, and that was one of the first things that they really wanted to look at. There is space on this site as well, space to trial the different technologies. For example, if wind turbines were something we were going to look at, we had to be sure that it was something that we could accommodate. There are other features on this site as well. There's an existing reed bed next to the site, which is going to come into play as part of the drainage solution for the development. But also there are services up nearby. There's water on site. There's also electricity adjacent to the site. The history of the site is quite an interesting one as well. It's a brownfield site, and it was previously used as a World War II aircraft repair centre. You can still see the remnants of the foundations on the site, although it has been slightly overgrown in recent years. But historically there were 3 buildings on the site, and again that lends itself quite neatly to what we're trying to trial here. We wanted to reflect the history of the site. There is 3 houses that we want to develop, and there were 3 buildings previously on the site. I'm going to look next at the dwelling design. What Phoenix were keen to do, and what I'm also keen to support them in, is that rather than having a typical modern looking energy efficient design solution, they wanted to show could traditional looking homes be built but with the same up-to-date standards and methods. They wanted to create a typical farm cluster which is common in the area and around about the site, and they wanted to fit in with the surrounding area. So really to some extent it's a modest approach that Phoenix were trying to take on here with regards to the site and the environment. The site itself, I mean, we're looking at a farm cluster, I suppose. There's the main house, which is elevation 1, I think John's now showing here, is a big house. It would use the BT passive system. I'll come on to the systems to be used in a moment. But there's the big house, there's the farmhouse, again a kind of traditional typology with the outbuildings, etc. And lastly there's what we've termed the gatehouse, right at the entrance to the development. And again you can see the elevations here. If we just move through onto the kind of arrangement of the cluster. They've been arranged in such a way as to be a kind of typical cluster development, and as I say, in that area, in the surrounding area, there are several of these already in existence. So we're not trying to do anything that's alien at all in terms of its setting, but rather we're trying to complement what's there, while at the same time doing something which is thoroughly modern and completely, as far as we understand it, unique at the moment. So I'll move on to the building systems which have been chosen. The first system to be chosen, that was for the biggest of the houses, is the BT passive system. The farmhouse is to use the CIPS panel system, and lastly the third type, or the third method selected, was an augmented timber kit. I'll just spend a moment or two talking about the BT passive system. It's a system which is relatively new to the market, and there have been some houses finished in the Fife area using this system. The main feature of the BT passive system is the continuous building insulation envelope. That's something which, as far as I'm aware, only the BT passive system has. It's the lack of, or the minimisation of cold bridging, which is its main feature. It is also a certified construction by the Scottish Passive House Centre. Again, it was the first system, as far as I'm aware, to achieve this accreditation. So that's what we're going to be using for the first house. There's a slide there showing a typical detail through the building envelope, and as you can see, from roof to wall, there really isn't much difference. It's a continuous building insulation envelope, timber frame, or a variation of a timber frame with a kind of large void which is filled with insulation. The next system to be used, and that was used on the second house, the farmhouse, is the CIPS panel system. Again, it's not as new to the market. In fact, there have been CIPS systems built in this country for around 40 years now. The main features of the CIPS system is it's an off-site prefab panel system which would minimise construction time on site. Again, it has high insulation values, as does the BT passive system. The last system that we're proposing to use, would be an augmented timber kit system. The reason for using that was that timber kit is fairly traditional in the area that we're going to be building in. It's a construction technique that most are familiar with, and so really what we're looking at is taking a traditional timber kit system and sort of augmenting it to a level where it is of a higher insulation value. In this case, what we're proposing to do is have an offset stud, again to increase the insulation void. In the case of all three systems, what we're looking at also is a very good value in terms of their airtightness. So really, in terms of the building, the main drivers in terms of design and common to all three systems would be good airtightness and good thermal insulation. Before I hand back to John, I'll just quickly tell you about the need for the study. The first thing is Finex were looking for independent expert advice, and they were introduced to Napier University through Fife Council's Building Standards Department. They were aware of lots of claims on performance and wary that some of these may be sales driven for the various sustainable technologies that are out there. So really what they were looking for was an independent voice in the midst of all the choices that were there. Initially it started as an aim to build an energy efficient home, and then it developed in a desire to be off grid. So as Finex and many of us are new to this type of technology and unaware of everything that's available, they thought that it would be good to turn to the Institute for Sustainable Construction to look into this with us. But in ourselves, we would also be unable to predict how these houses would perform, so again we're interested in a feasibility study, also to assess whether the site was suitable for some or all of the technologies that are out there, for example wind turbines, PV panels, that sort of thing. I'll hand back to John now, who I think is going to talk more about the report.
Good job, thanks Stuart. I'm going to go through briefly just the methodology that's set out on how we were to investigate these three dwellings that Stuart had designed. And essentially, Stuart had adopted a very strong, as you've seen from the slides, a very strong fabric first approach to all of the three dwellings. So whenever we came on board, we conducted a site survey, and this was a twofold approach. It was trying to see how much space we had for various technologies, and also to see the geographical layout and see what technologies we can omit from further research. The actual report was broken down to three main categories. The first were we modelled each of the three dwellings to establish the heat demand load. Then we simulated the occupancy to see what to try and get an estimation how much electricity it would need. And then from those we were able to size the type of technologies that we're going to provide on-site power and heat generation. So once we arrived at the site, and as Stuart mentioned, we established that there's no immediate mains gas or electricity connection, so we were looking essentially off-grid. Looking around the site and seeing away the lie of the trees and the local surroundings, we could rule out a number of technologies pertaining to wind and hydro, for example. And we also had access to a site, to an adjacent site to where the houses are proposed to be built, and this site was going to be able to house technologies and to allow for maybe a much larger farm type establishment of different technologies. And the report then speaks a bit about the foreseeable issues relating to living off grid and the challenges to providing sustained electricity, continuous electricity supply to a house all day, all year long. This is just another picture of the site. That essentially what I want to point out here was on this side here we've got a little arrow here. The red is, do we have an arrow? Oh, we do. The red box is essentially where the three houses were being constructed, something similar to what we have up there on top left-hand corner. And the blue site with blue outlined area here is the portion of the site we could establish a technology farm or technology base. There you go. So the evaluation of the buildings, for those not familiar with Scottish Building Standards Section 7, and I'm sure most of the viewers are. I know Kickstart have presented some webinars and conferences that go into this in a great bit of detail. This slide is essentially here to show the outlines of Section 7, and essentially it is a coloured labelling scoring system that looks to moving housing design to the next level of energy efficiency. Not all that similar within reason to the Code for Sustainable Homes, but same objective. It's an optional design category to look at making homes more energy efficient using sustainable technology, etc. As a reward-based scheme, which is awarded a colour based on silver or gold, and platinum is being introduced soon. Each of the silver and gold labels are met with 8 aspects. These 8 aspects have to be met in completion before that particular dwelling is assigned that particular colour of label. And the reason I mention this is our feasibility study was essentially looking at the first three aspects. This slide has changed. Anyway, I have the first 3 aspects, which I don't seem to have here on my slide for some reason. Anyway, the first 3 aspects relate to the carbon dioxide emissions based on the DER against the TER. Aspect 2, which is the space heating requirement, kilowatt hours per metre squared per year, and the third aspect was generating hot water based on renewables or recovery on site. So out of the 8 aspects, we essentially looked at those 3 as benchmarks of performance to compare the 3 designs of, and we omitted the other 5 aspects because they're more design based, looking at acoustic performance, looking at materials selected, looking at low flow water taps, accessibility, flexibility of design space, which is really within Stuart's remit. So we were looking just more specifically to look at what those buildings were in those 3 aspects. There we go. That's the reason why I missed a slide. So these are each of the designs that were put into the modelling software. The parameters or the categories based on each individual building component or the U value, wherever it may be, was either pre-selected by Stuart or by Drew about what the value should be for the openings, the doors and windows, or what the air tightness level should be, or whatever relating to those. Dwelling, the first dwelling we have marked here as dwelling A, was that property that's been designed under the Passive House standard that Stuart had mentioned. And essentially, Passive House have quite a rigid design parameter when it comes down to heat loss. So those values that were chosen there in the bottom table come from what the design standards were within Passive House. The values chosen to virtually construct the models for B and C, what I really want to focus on here is our thermal bridging and their permeability levels. So these are values that can essentially be manipulated or kind of massaged, if you like, within different modelling programs. And based on these values, you can essentially hit or miss a gold level standard by a couple of kilowatt hours per year per metre squared, based on what these values are. The values that we chose for B and C under those parameters essentially come from what we have experienced in our post occupancy evaluation, our building performance evaluation. Their permeability values, for example, were set at 3, and that essentially comes down to what we think, what we have experienced can be achieved realistically on site using modern methods of construction, and also these values will have to be proven, will have to be tested, completion testing as well. So the values put in here can bring down your annual consumption, heat demand consumption, but also needs to be justified at the end. The values here for the thermal bridging were also put into parameters within what we expect to see, and those were constructed simply on the back of virtually building these up within a certain modelling program. There we go. So, like I mentioned before, we virtually constructed the 3 dwellings in 2 pieces of software. One was a dynamic modelling software, the other was an analytical or a numerical piece of software. We noticed the outputs from both types of software produce slightly different results when it comes down to the space heating requirement, and in essence, the numerical modelling produced a much lower value, whereas the dynamic modelling produced a slightly higher value for various different reasons. And the outcome of that influenced the rest of the research, just the rest of the feasibility study, whereas we would foresee the dynamic modelling being quite close to what we expect to have witnessed when the houses are constructed and how they're going to perform, but ultimately it's the numerical modelling which is going to be used to achieve building standards section 7, and it's ultimately that's going to be compared against what the houses are going to be consuming. But on that end, we were using the dynamic modelling output to size our renewable technologies, which we'll come to in a few moments. This is the output from the numerical modelling. Essentially here, I've just shown this simply because I've also included Ofgem and DECC values for heat demand, kilowatt hours per annum. These aren't comparable values by any stretch of the imagination. These are just values that can contextualise what these houses will be demanding compared to what the averages are for the Fife area where the houses are going to be built. So just to give Phoenix and to add a little bit of context there. So I went through that slide earlier about what Section 7 is, and there's my slide there about the 3 aspects. I'm not going to go through that. That's simply for those who are looking to see a bit more on what Section 7 3 aspects were demanding. This is the table that was provided to us by the Scottish Passive House Centre. As I said, this is the values that we used to construct the first dwelling, the passive house dwelling. So out of the numerical modelling, what we seen was the dwelling A and C achieved gold under aspect 2. So they were under 30 kilowatt hours per metre squared per year heat demand, whereas B was slightly higher, it was just below 40, which meant it was in the silver category. the report goes on to say how we can manipulate building B to perhaps achieve that aspect for section 7, which we'll come to towards the end of the presentation. Right, I'm going to speak a little bit more now about how we calculated the power demand or the electricity required for the houses. What I think is important to mention here is the complexities when sizing technology to sustain off-grid properties. A lot of the work that we have done in the past with energy monitoring programming, we've seen that, essentially what you can pretty much guess yourself is a large part of the generation for electricity is going to be during the day, but a large part of the demand is probably most likely going to be in the evening, or even in parts of the year where the sun is at its lowest. So the overarching goal was to provide off-grid solutions. So what we had to do is we found or we developed a program that was to look at the occupancy pattern and to try and gauge a good understanding of what the power demand will be. So using a software calculator tool that was developed by Loughborough University, which we have manipulated to our own needs, we were able to predict the active occupancy and look at a number of parameters based on what we knew from what Phoenix and AD had provided us, was the number of occupants, the appliances, and we began to simulate scenarios of when these were going to be used, how they're going to be used, how energy efficient each appliance was, and then we developed different scenarios based on different times of the year, different times of the day, and ultimately to that end we were trying to achieve a peak energy demand and also a baseline energy demand, and also a yearly consumption that was going to be used to move forward and start to design the different technologies. So what we did and what we thought was prudent at the time was to develop two profiles, which was the higher model profile and lower model profile, and this was based on what we know from doing some behaviour monitoring energy with energy monitors in the past, where we see different trends within people's behaviour based on how they interact in their relationship with energy. So what we did essentially was we looked at maybe an energy frugal family who was going into these homes and they were keen to reduce their consumption, change their behaviour, modify their habits and reduce their consumption based on the fact that they are living off grid and lifestyle changes would have to be made. And then we also felt it important to look at a family who were living on grid, who came off grid and were bringing across a lot of their habits and habitual routines with them. Once again, I've just tabulated this against the Ofgem and DECC values for that area. Once again, not comparable, but good for context to see whereabouts this modelling system or this kind of modelling tool was pointing us towards. Out of that, we've seen that perhaps the lower end, the energy frugal family, if you like, it seemed to be difficult to provide a technology solution that was going to support the family for that year, and maybe the family growth, changes in family dynamic, increases in electronic purchases. So what we decided to size the power generation technology based on the higher end scale there. Going to go quickly through the review of technologies. I'm not going to go into this in too much detail because this particular topic has been covered with some depth by Julio Bros Williamson and Professor Tarek Munir, amongst others, in other webinars, and I would encourage you to watch those as well. But what I really want to point out here is that we had almost a two-stage approach to reviewing the technologies. From the very early stage, we were able to strip out a few technologies based on their applicability to the site, and then we were also able to focus more directly on the systems that we could look at into more detail. So this relates to, we didn't look at hydro or wind because the site wasn't suitable for either. We didn't have enough water, we didn't have a large enough water supply to generate any means of hydro, and the site was fairly shaded by by the local surrounding hills that ruled wind out as well. We didn't look towards heat pumps in much degree, and essentially the decision for that was based on the coefficient of performance, and we were looking more to generate power simply for the occupants' unregulated needs, as opposed to generating power that needs to heat, or needs to supply the needs of the family and also needs for a heating technology. So the technology we simply went down the road with was PV, biomass, and solar water heater, and we include solar water heater out of the aspect for the reason of aspect 3. This slide, we'll just put this slide in here to try and show what we were looking at when we were sizing the biomass heat boiler. And I'm not going to go through the slide point by point because it's all essentially there for you to see. But we sized the technology based on what the outputs were from our dynamic modelling system. We've seen what the values needed to be for the whole year round. We looked at getting different kind of real market quotes from various different companies who provide this type of system, and then ultimately we looked at towards a 9 to 12 kilowatt wood pellet boiler with a storage system above ground and an automatic feeder. And essentially we chose those to try and smooth the transition from on-grid to off-grid living. It's quite a big cultural shift and change whenever you start to have to look at maintaining these technologies. Not that these things can't become part of your habitual lifestyle, but essentially if you're looking at rolling this type of system out on a larger scale, you want to try and make it a bit more palatable to your prospective buyers. Hot water generation, we looked at solar water heaters. Essentially we modelled what the water heat demand would be on different simulation tools, and using the Scottish Building Standards Excel sheet there, we were able to size the technology within reasonable cost. It was able to produce 50% of the home's hot water demand, and that was to achieve section 3 of the Scottish Building, or aspect 3 of section 7. We also looked at the payback based on each of these technologies, and although the final details of the RHI haven't been published in any great detail yet, but from what we gathered from the consultation document, the lead up to the publication of this report, was that the focus is on having these technologies pay themselves back within 7 years. And if we can base any sort of forecasting on the previous RHI, we can see that the solar water heaters were around 18p per kilowatt hour of heat generation, and the financial incentive is going to last for 20 years. And through our calculations and doing a bit of modelling, we saw that the technology that we had chosen and the cost that we had got were able to fulfil those requirements, paying back within 7 years and producing that amount of heating for the properties. Again, this is simply just a breakdown of the system that was chosen for the site. Again, that's just there for those who are interested in any great deal. So looking now at the systems chosen for the power generation, for off-grid power generation, we looked at PVs with a battery bank, and we looked at quite a substantial, quite a healthy PV farm that was built. It was going to be erected at the site adjacent to where the houses are going to be built, and this came back to what Stuart was saying about having homes that were going to satisfy all the energy efficiency requirements, satisfy the desire to have renewable technology, at the same time to maintain this traditional facade. And one of those parameters was to trying to keep as many of the technologies off the roof and off the main building as possible. So what we then went on to do, we sized the PVs based on the generation, what we thought was applicable on the power generation modelling tool, and then we ran that through an economic assessment based on what the system would be achieving financially through the government incentive. And then we also looked at costing the system and having a capital expenditure of the system based on the return on the system. So what I want to point out here on this particular slide is that there was, for the three systems, there's quite a large financial investment to be put up front, and essentially the payback wouldn't occur within the 20-year life cycle of the feed-in tariff. And what I want to point out here is that this decision was made based primarily on what it could be, how it could be financially attractive, and there's lots of different reasons and different aspirations to creating off-grid living. But if one of them, which was the core to this, was what the return would be, or when it would pay itself back, this particular system, because it was off-grid, it retrieved the lower feed-in tariff because it was off-grid. It wasn't feeding back into the grid. The cost of the batteries as well. I know various other speakers have spoken about batteries in a bit of detail, but certainly the batteries will need to be replaced. The deep cycle batteries are more than likely need replaced across the lifespan of this of the feed-in tariff. And then there's also issues of leading to maintaining the batteries, etc. But this was an alternative that we investigated and we reported to Phoenix of what the challenges and what the barriers and what could be achieved by going fully off-grid. And what we had seen is, yes, it is achievable to a degree, but when it comes down to being financially attractive or not, it could be a slightly different story. So that prompted us then to go a little bit further and look at the possibilities of on-grid supply, and that's just relating to electricity. So getting electricity connection to the grid or to the site, and then not relying on issues of having to be off-grid or having to have batteries to be off-grid. And essentially the differences were going to be less technology required for the PV system to both generate and store that power. You can use the grid as a backup to prevent any scares of blackouts, etc. And what we saw from that perspective was that the connection to the grid was quite, electricity getting the grid to the site was quite an investment. But this is an investment that could potentially be wrapped up inside the building works itself. And what we would see is no batteries, and we wouldn't need a tracking system. They would then receive the higher feed-in tariff. They would also receive export tariff, and we would also be looking at a reduced capital cost investment for the actual technology alone, omitting the grid connection. The technology alone, the payback would be a bit more attractive because the payback does occur within the 20-year life cycle. And it reduces the need to invest in battery technology. So that was overall all of the different alternatives and options that we presented to Phoenix and to ad architects, and essentially we were looking to show the options that were available, what could be achieved, what they might struggle to achieve, and certainly with the designs that were outset from Stuart. Aspects 1 and 2 were fairly easily achievable, simply because these properties had a high thermal envelope, and after you add on the biomass boiler and you add on the PV system, the aspect 1 is fairly easily to achieve as well on numerical modelling. Coming back now to the labelling for the three dwellings. Dwelling A was passive house, and the passive house standards, if you kind of just loosely compare it to what aspect 2 was looking for, if you design a house to the passive house standards, you're going to achieve aspect 2 fairly simply, because it's much lower. That 15 kilowatt hours per metre squared per year is much lower than the 30 demanded by section 2 or aspect 2 gold. Silver missed out slightly, or B missed out slightly on the gold on that aspect, and doing a little bit of revised modelling on that particular building, we've seen that it could be achieved if we looked at more higher or better U value for the doors and windows, and if we looked at maybe decreasing the air permeability value, and if we looked at getting the thermal bridging value much closer to that akin to passive house. So these are altercations that can be made within the design program that Stuart can certainly influence, and he can manipulate those to a point that it is achievable, and at the same time achieves that Section 7 goal for Building B. I said Section 3, Aspect 3 was certainly easy to achieve by the solar water heater within reason. But if dwelling B was going to stay at silver, it would require a smaller solar water heater system to achieve the 5% from renewable technology as opposed to the 50%. So that's all I have to say on the conclusions for our aspect of the report and the feasibility study. All of these things have been translated over to both Phoenix and AD architects through the report, and now I'm going to go on. I'm going to pass back over to Stuart, who's going to speak a little bit about how they're going to move forward with the plans, how they're going to move forward with the recommendations, what their thoughts are, and the future for the site and the future for the 3 dwellings.
Okay, thanks, John. Yeah, just to update as to where we now are. We've received the report and we've been digesting the information. And following the report, Phoenix are now in consultation with 2 energy consultants and looking into the recommendations and weighing up the cost implications of various technologies. One significant, I suppose, aspect to come back from the report was the desire to be off-grid. That's something which has now been reviewed. It would appear that it makes a lot more sense to have a grid connection, at least from the point of view of feed-in tariffs, but also the start-up costs, the capital costs of investment in technologies, and also the payback period. So that has certainly influenced our thinking moving forward. We're currently assessing the practicalities of storing electricity to minimise grid use, but again, as we've heard from John, having the grid as backup is something that is now coming into our thinking. We're continuing to liaise with Fife Council Planning Department at the moment, and we're looking to make a planning application within about a month or so of now. At least now, making the application, we'll have an informed decision on the technologies that we're choosing and moving forward with. We'll continue to work in partnership with Building Standards at Fife Council as well. And moving on, once we get through the construction process, we'll be able to trial these technologies by actually living in the houses and recording and reporting on the data received. And as a result of all of these, we're looking to review our approach, and Vinex are looking to roll out a business model based on the information that we now have. So I think that pretty much wraps up where we are at the moment. I'm happy to throw this open to questions. I'll hand back to Branka.
Thank you very much, John and Stuart, for your presentations. And we are already receiving some questions. So I'll start with the first one from our online viewers. Martin Jarvie of KLM Partnership is asking, if you were to have included the connection costs, would the payback period still have been within the 20-year period?
That's a very good question, and essentially no is the answer to that. And the reason why we didn't chart that at the time is and this was translated through the report, but essentially the reason why we didn't add that in that calculation was that the electricity brought into the houses was going to provide much more benefits as opposed to having a battery bank sitting there in location, and it's also going to allow for family growth and that aspect as well. But as Stuart has pointed out there may be an area where we can provide some sort of compromise where a smaller battery bank is perhaps allocated to the site, which means there might be more of a desire to just live off that but still receive the maximum income from the feed-in tariff.
Second question from Harry Phillips of Holmes Miller Ltd. Can you explain what the future of feed-in tariff is, if you have any information on that. Or
future of the feed-in tariff. There's much better people than I who can forecast the future of the feed-in tariff. But essentially, what we're seeing now is quite an aggressive regression model from the feed-in tariff, where we're seeing milestones put into place for an incremental drop down on what you're going to achieve based on different systems. There already was a fairly big shake-up in as we all know, in the sector of the feed-in tariff, where the coffers were running dry, so the government had to readdress how much money was being made available for these technologies. Essentially, there's also been some added parameters placed on PVs, that a house has to be of a certain EPC value. You get a lower tariff. You have so many different, have more than one installation above a certain number, which in reality kind of impacts more on RSLs, etc. Or if you're looking at retrofit or you're looking at doing your stock. But the future of the feed-in tariff, I essentially don't know, but I know that the amount of money made available is going to decrease, and that's based, from my understanding, it's going to be based on the growth and the future of what the PV industry is. So there's plenty more information there on the DECC website, but that's kind of my take on it just now.
Michael Huey of Malcolm Holmes Ltd is asking, when considering the feed-in tariff model, did you take into account of the supposed saving on electricity costs if electricity is purchased from grid? The inclusion of saving on electricity might have helped the financial viability. Also, should the connection charge offset be taken into account too?
The first part of that I'll seek to address. No. Short answer. Long answer is that the houses were proposed, so we didn't have any idea what the houses were going to produce. We simply had a very simplistic model of what we think the family's going to produce. And you're right. You're right what you say. And in circumstances where we were going to retrofit PV, that's exactly the step we would have took. We would have modeled, or we would have monitored the electricity consumption through fuel bills, maybe, and saw what they're currently generating. Add a bit of forecast onto that, and then model that forward. But yeah, that does, in my opinion, that does seek to improve your payback period. But in this particular instance, I thought it was more true to this particular project specifically, because there was no realistic idea of what the houses were going to consume, and we essentially couldn't even use similar houses that were used by the Phoenix guys to even try to map that. But you're right what you're saying. The second part of that question was?
The second part, should the connection charge offset be taken into account too?
Yeah, I mentioned that slightly earlier with, I think Stuart Young answered that question. The reason I didn't add that in there was because connecting to the grid adds so much more potential and backup and security and for family growth, etc. And it also smooths that transition from on-grid to off-grid. Or it doesn't, it actually just makes it a bit easier to rely on your PVs, etc. And as certainly after speaking to the Phoenix guys, it was a matter of saying that, well, that cost might be able to be folded in onto the building works, and it mightn't really see that cost as such, so therefore should not be applied to the system, because we were simply just looking at the system, as it were.
A question from Stuart, or comment from Stuart Young of the Property Logbook Company. The payback period seems to be very long at 20 years, and I wonder, will people be willing to pay for something where they may not recoup the investment? General view being that the new technologies do not really add a great deal to the value of the property.
That's a very good point, Stuart. Couldn't agree more to that one, to be honest. It's more of a comment than a question, and I just want to say, yeah, you're right. And I say we probably have to see a cultural shift in how we value homes as well, and this will come down to the likes of RICS and surveyors. And maybe a challenge we might start to see whenever the Green Deal comes in. House A with all the bells and whistles, and House B with no bells and whistles. Surely those with PVs and surely those with solar water heaters should have a higher attraction to the buying public. And you're right what you're saying about the investment that's required there. So yeah, good point.
A comment from Dave Tremlin of Conservation General Services regarding to feed-in tariffs, connecting with the previous question. More specifically, what is the future of feed-in tariffs following Scottish independence? we might leave that for investigation.
Yeah, I would just say that I'm not going to forecast.
Yeah.
No comment.
A question from Anne West of Fleming Muir Architect. How local is a pellet supplier for biomass? CHIP may have provided a lower carbon footprint as may have been more locally sourced.
Yeah, that's a good point. I'm going to say something just now and pass over to Stuart, that's okay. Essentially, the biomass was attractive in our calculations because the cost provided by from forecasting is the cost of biomass similar to that of gas. The site adjacent, which I'll pass over to Stuart to talk about.
There's not really too much to add, but in terms of local, yeah, we have an area on site which will be used for coppicing and growing of biomass materials. So, yeah, we are extremely local when it comes to our supply on this site, fortunately.
Okay. A question from Ian Miller of ICOSIS Architects. Was the mechanical ventilation and heat recovery system used in all 3 houses?
Yes. Short answer, yes. Essentially because the air permeability value was lower than 5, so we needed to put that in there, and we wanted to max their energy. They had a strong envelope, thermally designed envelope, and to really bring that value of what the heat demand was going to be over the year, to bring that value within the limits of Section 7, Aspect 2, the properties, it almost merited the need for MVHR, so they were designed in there. Certainly it was going to be essentially added to dwelling A because that was my passive house design, and that requires it. And we needed to bring the values, their permeability values for B and C need to be low as well to meet Section 7, so they needed that recovery under the ventilation standards.
Mohammed Abdul Wahab of Heriot-Watt University is asking, is it accurate to say that investment in PV in these dwellings isn't economic and a high-risk strategy when it comes to achieving energy security?
Is it what, sir?
Is it right to say that investment in PVs, photovoltaics in these dwellings isn't economic and a high risk when it comes to achieving energy security?
Yeah, like you said, David. I don't say we said that really at all. It's not accurate. No, investment in PVs and having a catch to the grid and simply benefiting from that higher feed-in tariff seem to be very attractive, and certainly moving forward to this energy sufficient and more sustainable future, and we're looking at towards decarbonising the grid, and we're looking at creating more on-site generation for electricity, for power for our homes. The PV industry has been great at providing that, so it does, connecting to the grid does seem more economical. There's different aspects that, as pointed out, about the connection to the grid cost there may be associated, but essentially, it's economically viable to have the PVs attached to the house and connected to the grid.
Okay. While we are waiting for other questions from our online viewers, I have prepared a few. Could you tell us, please, when you plan to build these buildings and whether there will be any monitoring? Who would like to? Drew, if you would like to answer that.
Obviously, the stage that we're at just now is obviously still digesting all these reports from Napier, which has been a great help. We're looking really to have a planning application in place by sort of end of February, beginning of March. We would have to say realistically, hopefully 2014 would be we would like to be starting these properties, and yes, there will be energy monitoring through once we start building them and living in them for 6 months to a year. We will have reports every maybe quarter, certainly every 6 months,
What are future plans for research in this area and research that will be undertaken at the Institute for Sustainable Construction?
Yeah, well, certainly from a micro level, we are keen to follow Phoenix on this journey. As Stuart Andrew has pointed out, we're keen to going back once these houses have been erected, and with a whole host of different post-occupancy evaluation monitoring tools, we could take a look and see how the houses are performing. And it's of great interest to us to see exactly what the generation and what the consumption is going to be based on our forecasted values, and that'll be a great insight to us. And the other aspects to that as well, about looking at perhaps how the houses or tightness value have degraded over a particular space of time or not, essentially was good. From a more macro level, the SEC within the Institute will continue to support SMEs, will continue to provide advice and guidance when needed, which we've been doing for quite some time now. And we're also, moving forward, we're looking at strengthening our understanding and our work within the building performance evaluation, looking at behaviour changing models within the energy consumption level, looking at developing and reviewing micro technologies. So the future's quite bright for us just now, and we're keen to continue to work with Phoenix and work with similar companies.
More questions coming and comments. One from Harry Phillips of Holmes Miller. Cost in use and payback are based on current energy costs. However, we know that these will inevitably increase. This fact will surely alter the assessment of photovoltaics, especially when improvements in technology, efficiency and cost are taken into account.
Well, our trajectory model was based on, if I understand the question correctly, it was based on decreasing in generation and having having an inflation value added to the feed-in tariff, and having an inflation value based on, for example, for the on-grid connection, what the current electricity price is and what the electricity price will be, and what FIT is following what their inflation value is going to be as well. And there's obviously a value related to how the panels are going to degrade in efficiency as they go down. The values that we use in this report were based on what we know from systems that currently exist, and from what we know from previous feasibility studies we've done this area.
Comment or question from Huda Salmon of Robert Gordon University. In what ways the systems you have chosen have affected the design of the dwellings under investigation?
Well, at this stage they haven't had any direct input onto the design, because we're still digesting that, and we're moving forward from the receipt of that. Having said that, the way that they've been designed, for example, orientation, which is one of the main things in environmental design, to some extent has been taken out of the equation, because the photovoltaic panels, for example, are going to be sited off the buildings. So to some extent it's not a huge influence. The other thing is that the main design aspect that we tackled was the building envelope, and with it being highly insulated and very airtight, again there's not as much influence as there might possibly have been from the report. But what I would say is we are still digesting information, and it may yet feed into some aspects of the design.
Graham Drummond of Passive House Associates asks, the existence and level of feed-in tariffs are always going to be controlled by politicians. How can proper decisions be made by designers and building owners? $1 million question.
Yes, it's a good point to raise. Certainly in this type of forum, it's a difficult one to talk on, but I get the point. Yes, it's see where it's coming from there.
Yes. Another comment from Harry Phillips of Holmes Miller. I don't think enough is made of the health benefits of potentially improved indoor air quality due to mechanical ventilation and heat recovery. Maybe you can add some points here.
Yeah, it's for me, from where I am just now, it seems that we tend to have two camps. We have pro-MVHR and anti-MVHR. And certainly there's a webinar I know on indoor air quality, and certainly Kickstart had a conference on, which was extremely interesting. But I would say that there's certain cultural shifts that may have to go through, particularly here when it comes down to MVHR. And I think on one hand we do have the improved indoor air quality, but at the same time too, what we have seen from work coming out of the Macintosh School of Art is if those air filters aren't maintained, and we do need to have that shift in how people maintain their homes, because it's not this kind of utilitarian future where we have little cubes we kind of live in. It's more of we need to interact with the house for the house to provide the best environment for us. But certainly I would recommend that you have a look at that DVD that Kickstart have on air quality, which covers that topic quite well.
Thank you. Ken Mackey of Shape Associates comments, could it be argued that in determining the need for grid connection at this time, that you are proposing the more fuel efficient Mini for everyday use while keeping a Jag in the garage for standby? Will this ever be economic? Before submitting my question, I see what Graham Drummond has asked. This hits the nail on the head. Any comments there? No. If not, we will continue with next question and comment. Mohammed Abdul Wahab of Heriot-Watt University. Energy storage is still a developing technology, and as such achieving energy security and independence of the grid is questionable. What are your thoughts on that?
Yes, good point. I would say that certainly we have relationships with companies in the Highlands and Islands who the aspiration of connecting to the grid isn't even on the cards. So therefore they do rely on batteries. And certainly, I know Professor Tarek Munir has a webinar on PVs and talks about batteries to quite a bit of extent. So I would agree that battery technology, we seem as a growing evolving kind of culture, we seem to be more reliant on batteries in absolutely everyday life, and it almost just seems ironically apt that we will be relying on batteries to store our generation. I think what will probably facilitate that in a bigger way is electric vehicles, which may be able to facilitate that transition much easier. It also seems with electric vehicle, and certainly having an infrastructure in place to even power the electric vehicle, it seems to be there's a big investment there as well. And certainly from a, having that particular aspect built into the built environment, we're kind of at the mercy of the larger car building manufacturers coming down to more finite details about how are we going to replace the battery in the car? Are we going to end up charging the battery in the cars? There's so many questions to be answered there, but I would say that potentially electric vehicles might facilitate that transition a bit smoother.
That's a nice lead to what I'll say later about our forthcoming event on electric vehicles and the built environment, because that is exactly what we want to explore at the conference on 31st of January. That will be a live conference here in Glasgow. So I would encourage all our viewers to find out more information on our website about this forthcoming event. One more comment from Harry Phillips of Holmes Miller Ltd. It seems like a lost opportunity that the house designs don't reflect passive solar design, i.e. large south-facing windows for winter, again with appropriate shading to avoid summer overheating. Probably that's how the design will develop, as you have suggested.
Well, I've suggested, we are still reviewing these aspects, but as I'm sure Harry Phillips knows, there are a lot of other things that come into play when you're laying out a site, regards planning and various other things. So yes, as far as possible we'll be making as much as we can of the passive opportunities, but again there are certain topographical and other things that come into play that we kind of have to work with what we've got to some extent as well.
Not every house can be angled.
No.
You know what I mean, to the...
But shading against some gain of heat in summer would probably be something that
could
can
also
be added. Another comment also from Harry Phillips. The answer on mechanical ventilation and heat recovery highlights that people have a responsibility to manage their own lifestyles to achieve best outcomes. Current behavior is essentially lazy and dependent on others to solve all the problems. Those who make the effort will benefit. Those who don't will pay. What's so hard about cleaning a ventilation filter anyway?
Listen, you're touching on a topic that I feel quite strongly about as well, and it kind of brings me back, to this ideological utopian world where we have boxes to live in. Homes are boxes to live in, and we can self-sustain within those boxes. And it, as you quite rightly point out, it doesn't take a lot, and it even comes back to homes that are built homes we're seeing being built now that are highly thermally insulated envelope. They're somewhat leaky, so that they don't have to implement MVHR, because there perhaps is a cultural kind of concern within perhaps the house builder, or what we perceive that people want to see in their homes, and having an MVHR there with associated noise. And there's, whenever we break into these areas of making homes with low air permeability values, we inherently need to have that air changes, and that's facilitated through the MVHR. And I agree with what Harry's saying here. It's true to the point where whenever we start to implement MVHR on a larger scale, and we're beginning to see them now even on social housing, RHL or RSL properties as well, and you tend to find that it only takes a few that are very badly installed to create a bad name. It's either too noisy, or it smells, or it lets in cold air. It only takes a few bad installs to try and that would shake the confidence. But I totally agree, and I think we see it with condensation as well, where people don't, it's difficult to try and categorize people, but we grew up in houses that were able to some extent, before we went down the route of highly thermal envelopes. Houses were fairly leaky, etc., but they were able to mitigate their own condensation risk and any interstitial condensation episodes. And now we're seeing highly efficiently built properties, and trickle vents aren't open, windows aren't open, and we're seeing mold growth, deterioration of the window seals, etc. So I would agree that a cultural shift is needed to facilitate MVHR, the same way too it needs to facilitate, houses who need to look after the condensation. And these aren't just for new builds; these are ones that are already established. Retrofitting.
Graham Diamond of Passive House Associates also comments: as government is investing heavily in wind power to generate grid electricity, grid connections for remote properties should also be subsidized to make it cheaper to connect.
Mm-hmm. Yes. Yeah.
Then we have also comments from Stuart Young of the Property Logbook Company. Behaviors. We know from 2 energy efficiency projects we are running for Scottish Water and Scottish Government that these projects are really about changing behaviors. No amount of technology will work without getting occupants to change their behaviors, a very hard nut to crack.
Yes, I would agree with Stuart there, and I think I've seen Stuart present on a few occasions at Kickstart, and he holds much the same views that I hold when it comes down to behaviour change, albeit on the topic of energy monitors, which I believe in quite strongly. And I would say there is a piece of technology that, and it really does depend on what projects you're looking at, and we can isolate particular projects and say that proved useful, that proved unuseful, but certainly from a holistic perspective, and certainly on what we see from large-scale literature reviews done by DECC and the roll-up to the rollout of smart meters, that when it comes down to not just provoking behaviour change, and it's not just behaviour, it's also about habitual routines. And the best way to promote behaviour change is to fit a regime in around an occupant or a family's lifestyle that will create a habitual routine to be repeated, and that becomes a mainstream behaviour. And from there we start to see long-term, as we said, behaviour change. And I think behaviour change is sometimes, it's one of those words that's now been polluted in within the mass media. It seems a bit aggressive. I would say it's more about behaviour adaptation to the new future. And what I would say is there's definitely a part in time where people will start to stand up and take notice, and a lot of that's done through fuel poverty, but I don't think that's the only driver. So we will need technology to promote behaviour change and to sustain behaviour change, but ultimately it's a difficult nut to crack, like Stuart said.
Another small comment from Harry Phillips of Holmes Miller. I'm planning to build my own airtight house with MVHR, so ask me what I think about it next year. And a comment from Graham Drummond of Passive House Associates. No noise from properly designed and installed MVHR systems. We shouldn't not install because expertise needs to be improved.
I would agree with that wholeheartedly, Graham. And what I would say is that if we take a look back just a few days ago to a presentation on performance gap from Julio Ross Williamson, one of the indicators that were pulled out of that particular research was there's a gap in on-site responsibility. And certainly, if we're setting out to achieve, and we can forecast with as much reliability as we want, but with more houses need produced to house the population. We also need to have a certain level of on-site generation. We also need to have a certain level of thermal efficiency. So these are huge targets, huge drivers, vehicles of drivers that the house builders need to go on quite quickly. And like I said before, and I will come back just to make a point clear from earlier on, a properly designed MVHR system I would condone fully. But it only takes a few bad installs to put a house builder off using that system, or to put a RSL off using that system. But he's right. His point is well made.
Here is a related question from Mohammed Abdel Wahab of Heriot University. Wouldn't the investment decision in appropriate renewable technology be affected by the availability of competent workforce for successfully installing and maintaining these technologies?
Yeah, well, I think that comes back slightly to what I pointed out just a few moments ago about the previous Kickstart, where Julio and the Morrison Partnership, Dr. Purdy and Julio Ross Williamson, had spoke about the issues to achieving long-term low energy efficiency homes, and one of the points was, is there a responsibility gap on site? This is all still quite conceptual at this stage, and if Stuart or Drew want to weigh on that point, but I think the real point here is the fact that we probably see a bigger discrepancy between in mass built homes than we might see in these three, and that's unfair, but it may be the point where Drew's team might do a lot of the work as well, and his company might do a lot of the work as well, and that will have its own vested interests. It'll be much easier to keep an eye on because these houses are being built specifically. But on a larger rollout scale, certainly what we might see, and we can see it as well from post-occupancy evaluation programs that have been integrated right across the country, not just at Edinburgh and Napier, but other universities as well, that those that are built don't always meet up to those that are designed, and we see compromise in thermal envelope. We see large dark patches in IR images. We see MVHR systems, saying it again, that weren't installed correctly. We're seeing PV systems that weren't even connected correctly. We're seeing all these problems. These are isolated issues, so I don't want to try and convey this as a countrywide issue. But I think we'll always see that slight gap between design and build, and I would encourage them to go back and see that Kickstart by Julio Ross Williamson.
Yes, that was our seminar just a week ago.
It was.
Yes. Another suggestion from Harry Phillips of Holmes Miller. I think that all house layouts can be influenced by a passive solar design approach, especially when you have the opportunity to design a cluster of buildings. A standard approach to room layouts probably creates problems which cut across opportunities to create attractive, sunny and well-lit space. And also comment from Stuart Young of the Property Logbook Company. Interesting project. We don't have any more questions, maybe some will come, but in the meantime I would like to first of all to thank you for your presentations, and now to say a few words about our forthcoming events. First of all, on 29th of January we have afternoon event on LED lighting quality and performance. This is an event that will take place at Glasgow Caledonian University. On 31st of January, we have a conference on electric vehicles and the built environment. I mentioned that earlier. This is really a relevant conference to what we have been talking about, because electric vehicles could also be used as a storage for electricity. And finally, on 6th of February, we have a conference, whole day conference, on the use of recycled materials in construction, which will take place in the Lighthouse. We have some international speakers here, some architects are speaking, some researchers in recycling of aggregates for green concrete, and so on. We will be offering a special discount of 30% to the online viewers today for the forthcoming live events. So please quote webinar 30, meaning 30% discount, when you book a place for any of these 3 live conferences that will take place in Glasgow in future weeks. Information about forthcoming webinars will be published soon in our monthly e-news at the end of January. I don't see that we have any further questions or comments. Oh, here is one from Martin Jarvie of KLM Partnership. Is Harry Phillips going for the Guinness Book of Records in the number of questions that can be asked on a Kickstart webinar? Well, we appreciate all the questions and comments, because I think we all learn from these comments. So I would encourage everyone to ask questions and send us comments regarding presentations. So I hope you have enjoyed today's webinar. Once again, thank you to our speakers, and thank to everyone who has participated with the questions and comments. Thank you very much.